What if the universe suddenly broke one of its own rules? Imagine the entire cosmos as a vast orchestra, where every planet, comet, and star contributes its own subtle vibration to an endless cosmic symphony. Most of the time, those notes blend together into a natural harmony shaped by gravity, chaos, and time. But on December 22, 2025, something happened that sounded like a wrong note in that cosmic music, a signal so precise that many scientists quietly began asking a question they never expected to ask. At exactly 2 UTC, astronomers analyzing the interstellar object known as 3I Atlas discovered a rotational pattern that defied expectations. The object was spinning once every 7.136 hours with a level of precision so exact that the probability of it happening naturally was practically zero. To understand why this shocked researchers, you need to remember where this object came from. Interstellar bodies travel unimaginable distances through the dark emptiness between stars. They are battered by collisions, gravitational pulls, and violent ejections from their home systems. By the time they drift into another star system, they should be unstable, chaotic, and tumbling through space. But 3I Atlas was not tumbling. Instead, it rotated with the calm, steady rhythm of a perfectly engineered mechanism, the kind of rhythm you would expect from a finely tuned clock. And even more curious, the axis of that rotation pointed almost directly toward our Sunday. At first glance, this might not sound extraordinary, but in the field of rigid body dynamics, natural objects rarely behave with such stability. When an asteroid or comet is thrown out of its home system, the violent forces involved typically leave it spinning wildly. Scientists call this state non-principal axis rotation, though most people simply know it as tumbling. Without an atmosphere to create friction or a nearby gravitational body to stabilize it, that chaotic motion should continue indefinitely. Yet, telescopes in Calabria, Italy recorded something completely different. Data simulations showed that 3I Atlas was rotating with astonishing stability. The rotation period varied by only 0.01 hours. That level of accuracy is almost unheard of for a natural object drifting through interstellar space. This is where the mystery deepened. As 3I Atlas approached the Sun, the heat began to affect its icy surface. Like every comet, the warming ice began to vaporize. That process creates jets of gas that blast outward like tiny rocket engines. These jets normally push a comet slightly off course and change its spin. In fact, scientists expect such forces to dramatically alter a comet's rotation, especially near the Sunday. But when the Hubble Space Telescope carefully monitored the object, something remarkable appeared in the data. Even as solar heating increased dramatically, the rotation period of 3I Atlas barely changed at all. It stayed locked to its precise 7-hour rhythm. For a natural comet, that stability should be impossible. The measurements showed that water production from the object increased nearly 20-fold as it approached the Sunday. Those gas jets should have altered its spin by minutes or even hours, yet the rotation remained almost perfectly constant. This strange behavior forced researchers to examine the object more closely. When they analyzed the pattern of gas jets emerging from the surface, they discovered something even more intriguing. The jets appeared to be spaced almost perfectly 120 degrees apart. In physics, three equal forces spaced at 1, 2, 0 degree intervals cancel each other out. Their torques balance, producing no net rotational change. It is the same principle engineers use when designing stabilization systems. Nature is creative, but geometric perfection like that is rare. And that raised a disturbing possibility. What if those jets were not random vents in an icy surface? What if they were arranged intentionally, forming a kind of natural torque-canceling system that allowed the object to maintain its steady rotation? Then came the alignment problem. Astronomers discovered that the rotation axis of 3I Atlas was pointed toward the Sun with an accuracy of roughly 20 degrees. In celestial mechanics, the odds of a random interstellar object aligning this way by chance are extremely small, estimated at around 3%. Yet there it was. That alignment could serve a very practical purpose. If an object were designed to collect solar energy, positioning its equator toward the Sun would provide steady heating across its surface. This would prevent structural damage from uneven temperature changes while maximizing energy intake. In other words, the object would not merely survive its close encounter with the Sunday, it would use it. The numbers surrounding the object's spin only added to the mystery. Scientists measured its equatorial velocity at around 320 meters per second. That speed pushes the limits of what a natural comet could survive. Most comets are fragile collections of dust and ice held together by weak forces. At such speeds, centrifugal forces should tear them apart. Yet 3I Atlas remained intact. This suggested something unusual about its internal structure. Theoretical models proposed that the object might contain a strong internal framework, possibly a rigid skeleton capable of withstanding enormous stresses. Instead of being a loose pile of icy debris, it behaved more like a solid, engineered mass. Its total weight was estimated at around 33 billion tons. Holding that mass together under such rotation requires immense tensile strength, far beyond what typical comet material can provide. But the most fascinating discovery emerged when scientists studied the slight wobble in the object's jets. During each rotation cycle, the jets shifted their direction by roughly 20 degrees before returning to their original orientation. At first, this looked like random movement. But after multiple observations, researchers realized the pattern repeated perfectly every 7 hours. It wasn't random at all. It looked like a scan. Each rotation seemed to sweep the surrounding space in a complete 360-degree survey, as if the object was examining everything around it, including us. If this interpretation is correct, then the 7-hour spin is not simply a mechanical feature. It is a repeating cycle, a kind of cosmic heartbeat, a rhythm that allows the object to monitor its environment with remarkable consistency. This possibility has pushed some researchers to consider a radical idea. According to the famous Kardashev scale of civilizations, a Type 1 civilization can control the energy resources of its planet. A Type 2 civilization, however, can harness the power of its entire star system. And if such a civilization exists, it might send probes across the galaxy. Probes designed to watch. Probes designed to wait. And as the data surrounding 3I Atlas continued to accumulate, the quiet question growing inside the astrophysics community became harder to ignore. What if this object was not just drifting through our solar system? What if it had arrived here for a reason? Because the deeper scientists looked into the strange precision of that 7-hour rotation, the more they realized that the mystery was only beginning, and what they discovered next would make the situation far more unsettling. If you want to uncover what scientists found when they analyzed the thermodynamics behind this impossible rotation, make sure to stay with the video, because the next discovery changed the entire interpretation of 3I Atlas and raised a possibility that many researchers are still struggling to explain. The deeper scientists examined the strange behavior of 3I Atlas, the more uncomfortable the data became. At first, the 7-hour rotation seemed like an odd curiosity. But when researchers applied the laws of thermodynamics to the object's motion, they discovered something that should not exist in nature. To understand why, we need to talk about one of the most fundamental principles in physics, the second law of thermodynamics. In simple terms, this law states that every natural system moves toward disorder. Energy spreads out, structures decay, and perfect order slowly dissolves into randomness. It is the reason ice melts, stars burn out, and galaxies gradually lose their structure over billions of years. But the rotation of 3I Atlas appeared to be doing the exact opposite. Instead of drifting toward chaos like a natural object should, it maintained a perfectly stable rhythm. A 7-hour cycle that remained almost unchanged, even while the object endured extreme forces from solar heating and outgassing jets. In the world of astrophysics, such stability represents an incredibly low-entropy system. And low-entropy systems do not normally exist in uncontrolled environments. When a comet approaches the Sun, its icy surface begins to sublimate, releasing enormous jets of gas and dust. These jets behave like tiny thrusters, firing in unpredictable directions. Over time, they change the spin rate, alter the rotation axis, and often send the comet into a chaotic tumble. This process is called non-gravitational acceleration. It is common, measurable, and expected. Yet once again, 3I Atlas refused to behave normally. Observations from the Hubble Space Telescope confirmed that even during its closest approach to the Sun, the object's rotation remained nearly unchanged. The period varied by no more than 0.01 hours. That level of precision is so extreme that many physicists initially suspected a measurement error. but repeated observations confirmed the same result. Something was keeping the object balanced. That discovery forced scientists to consider a very unusual possibility: active stabilization. In engineering terms, maintaining such a precise rotation while losing mass would require continuous adjustment of the object's internal balance. Imagine trying to spin a massive wheel while pieces are constantly breaking off. Without constant correction, the wheel would wobble and slow down. But if the system could move its internal mass in real time, it could maintain perfect equilibrium. Computer simulations suggested that 3I Atlas might be doing exactly that. The model showed that if the object contained internal components capable of shifting their position, it could constantly adjust its center of mass. That would allow it to preserve its exact rotational rhythm despite the chaotic forces acting on its surface. In modern spacecraft engineering, this concept is already familiar. Satellites often use reaction wheels to maintain orientation. These spinning wheels inside the spacecraft create counter-torques that stabilize the craft and keep its instruments pointed in the right direction. The Hubble Space Telescope itself relies on such systems. But scaling that technology to an object weighing 33 billion tons would require engineering capabilities far beyond anything humanity currently possesses. And yet, the behavior of 3I Atlas seemed consistent with such a system. The evidence became even more striking when high-resolution images taken in early 2026 revealed the geometry of the object's jets more clearly. Instead of appearing randomly scattered, the three jets formed a pattern that looked almost mathematically perfect. They were spaced at roughly 1-2-0 degree intervals around the object's equator. In vector physics, this configuration produces perfect torque cancellation. Each jet's thrust balances the others, preventing any change in rotation speed. This design principle is common in engineered propulsion systems, but it is almost unheard of in natural comet structures. Comets usually develop cracks, uneven vents, and irregular fractures. Their gas jets erupt from weak points in unpredictable patterns. They do not form equilateral triangles with perfect spacing. Yet that is exactly what the images suggested. And the deeper scientists looked into the object's orientation, the stranger the situation became. Statistical analysis revealed that the spin axis of 3I Atlas was aligned with the Sun-Comet line within roughly 20 degrees. That might not sound extremely precise, but in astronomical terms, it is remarkably unlikely. For a random interstellar object, the probability of such alignment is estimated to be less than 3%. It would be like throwing a dart from across a football field and striking the bullseye of a moving target. So why would the object be oriented this way? From a purely practical perspective, the alignment offers several advantages. If an object spins with its equator facing the sun, the heat distribution becomes evenly balanced. That prevents dangerous thermal stress that could fracture fragile material. But it also allows for continuous exposure to sunlight. And sunlight is energy. For a system designed to harvest solar power, this orientation would be extremely efficient. By rotating in this configuration, the object could maintain a steady supply of energy without overheating any single section of its surface. It would essentially turn the sun into a charging station. Then came another unsettling measurement. Researchers calculated the equatorial velocity of 3I Atlas at roughly 320 meters per second. At that speed, the centrifugal forces acting on the object are enormous. Natural comet material is extremely weak. Most comets are little more than frozen rubble piles, held together by faint molecular forces. At such rotational speeds, those forces should fail. The comet should break apart. Fragments should scatter through space like debris from an exploding mountain. But 3I Atlas remained perfectly intact. This suggested that the internal structure of the object might be far stronger than any natural comet. Some theoretical models propose that the object could contain a rigid internal lattice capable of withstanding massive stresses. Possibilities included advanced composite materials, or even a network of ultra-strong carbon nanotube structures. While such materials exist in experimental form on Earth, building a structure of that scale would require technology far beyond current human capabilities. But the most disturbing possibility involved the purpose of the rotation itself. When scientists analyzed the subtle oscillations in the object's jets, They noticed a repeating pattern that occurred during each 7-hour cycle. The jets shifted their orientation slightly, then returned to their starting position with remarkable precision. The motion resembled the sweeping motion of a radar dish. Each rotation appeared to scan the surrounding environment. And if that interpretation is correct, then the object might not simply be stabilizing itself. It could be deliberately surveying everything around it. Planets, magnetic fields, radio signals, satellite traffic. In other words, the entire solar system. Some researchers began comparing the object to a theoretical concept known as a Bracewell probe. This idea, first proposed by physicist Ronald Bracewell, describes an autonomous interstellar probe designed to travel across the galaxy and observe developing civilizations. Such probes would wait silently for millions of years before activating when they detected signs of technological activity. In other words, motion becomes the scanning instrument. When researchers applied this concept to the rotation of 3I Atlas, the similarities were difficult to ignore. As the object rotated once every 7.1 hours, its 3 perfectly spaced jets appeared to function as reference points, stabilizing the motion with extraordinary precision. The result was a rotating emitter system capable of mapping the surrounding space with astonishing detail. If that interpretation is correct, then the object was not just spinning, it was surveying. Each 7-hour cycle effectively created a complete 3-dimensional scan of the solar system. Every orbit, every planetary magnetic field, every artificial radio signal produced by human technology would pass through its observational sweep. With enough cycles, the object could build a detailed map of the entire region. Not just our planets, our civilization. Through a theoretical framework sometimes referred to as the Kaku scale, physicists classify civilizations based on the amount of energy they can control. A Type 1 civilization controls the energy of its home planet. A Type 2 civilization can harness the energy of an entire star. If such a civilization existed somewhere in the galaxy, sending autonomous probes to observe developing worlds would be a logical step. And the behavior of 3I Atlas increasingly resembled such a probe. Further analysis revealed another strange detail hidden within the rotation itself. As the object spun at its measured equatorial velocity of roughly 320 meters per second, it passed through the magnetic field of the Sunday. According to the laws of electromagnetism, any conductor moving through a magnetic field experiences a Lorentz force. This interaction can generate electrical currents. Theoretical models suggested that the massive rotating body of 3I Atlas might be using this interaction to create a magnetohydrodynamic field, sometimes abbreviated as MHD. Such a field could allow the object to convert its rotation and the sun's magnetic environment into usable energy. In simpler terms, the object could be acting like a giant electromagnetic generator. Its enormous mass, estimated at roughly 33 billion tons, combined with its rotation, could transform it into something resembling a cosmic tuning fork. As it moved through solar magnetic field lines, it would produce subtle electromagnetic signals that could interact with surrounding space. This would allow it to listen to the solar system. Radio transmissions from Earth, signals from satellites, fluctuations in planetary magnetic fields, everything. But perhaps the most disturbing discovery came from studying the object's brightness. Normally, comets display chaotic light patterns. As ice vaporizes and fragments break away, their brightness fluctuates unpredictably. The resulting light curve resembles a flickering candle. Yet 3I Atlas behaved differently. Its brightness oscillated with a stable amplitude of approximately 0.3, and that oscillation remained consistent to within 0.01% throughout its passage near the Sunday. In control theory, maintaining such precise stability requires continuous feedback adjustments. A closed-loop system. That means the object was not simply reacting to its environment, it was actively correcting itself to maintain perfect operational conditions. Every 7 hours, the system completed another cycle, another scan, another data collection phase. But one question still remained unanswered. Where was that data going? According to the principles of special relativity, information cannot travel faster than the speed of light. Any signal transmitted from 3I Atlas would require a destination within range of normal electromagnetic communication. Naturally, scientists searched for transmissions directed toward Earth. But that is not what they found. Deep Space Network receivers detected a series of faint, phase-shifted pulses emerging during specific points in the object's rotation cycle. These pulses were not aimed toward Earth, the Moon, or any known spacecraft. Instead, they were directed toward a very specific location in space. The Sun-Earth L1 Lagrange point. This region sits roughly 1.5 million kilometers from Earth and represents a gravitational balance point where objects can remain relatively stable. Space agencies often place observation satellites there because it provides a constant view of the Sunday. But the idea that 3I Atlas might be transmitting signals toward that location raised a chilling possibility. What if something was already there? Theoretical physicists began considering the concept of a distributed probe network. In such a system, one probe would perform mobile observations, while another unit, positioned in a stable orbit, would function as a relay station. The scanning unit gathers data. The relay sends it home. If this interpretation is correct, then 3I Atlas may not be alone. Somewhere near the L1 region, a hidden transmitter could already be waiting to forward the results of this 7-hour survey across interstellar distances. Meanwhile, laser measurements continued to analyze the structure of the object itself. Despite the extreme centrifugal forces created by its rapid rotation, the nucleus of 3I Atlas remained rigid and unchanged. A natural comet would begin to flatten at its equator under such stress, eventually breaking apart. But this object did not deform at all. It behaved like a solid monolith. That suggests the presence of an internal skeleton made from extremely strong material, possibly a metallic lattice, or a network of advanced carbon structures capable of holding the massive body together. As the object slowly moves away from the inner solar system and begins its long journey back into interstellar space, scientists are left with a conclusion that feels both extraordinary and deeply unsettling. The 7-hour rotation of 3I Atlas may not have been a random feature. It may have been a clock, a timer that controlled the length of its observational mission. If that mission has now been completed, then the object has likely gathered everything it came to collect. A map of our planets, a record of our signals, a profile of our technological activity. In other words, humanity may have just been examined, measured, and cataloged by something that arrived silently from the depths of interstellar space. And as 3I Atlas disappears back into the darkness beyond our sun, carrying its data with it, one thought continues to echo through the scientific community. For the first time in human history, we may not have been the observers. We may have been the subject of the observation. If this discovery fascinated you, and you want to explore more mysteries of the universe, don't forget to like the video, subscribe to the channel, and stay with us for more deep dives into the cosmic phenomena that could change how we understand our place in the universe.